Chapter 12, Compound Interest and Present Value. In the first main unit, we'll talk about compound interest, future value. We'll discuss how to compare compound interest with simple interest, as well as how to calculate the compound amount and interest manually and by table lookup, and explain and compute effective APY. So far, when we've talked about interest, we've only talked about simple interest, which is interest on principal alone. Simple interest is paid either at the end of a loan period or deducted in advance. Interest can also be compounded. Compounding involves the calculation of interest periodically over the life of the loan or investment. After each calculation, the interest is added to the principal. Future calculations are on the adjusted principal, the old principal plus interest. Compound interest, then, is the interest on the principal plus the interest of prior periods. Future value, or FV, or the compound amount, is the final amount of the loan or investment at the end of the last period. Don't be concerned with how to calculate compounding right now, but make sure to try to understand the meaning of compounding. We also discuss present value, the value of a loan or investment today. When we discuss compounding, compounding can be done on different bases. The first, if something is compounded annually, interest is calculated just once a year, therefore there is one period for calculation. If interest is compounded semi-annually, interest is calculated on the balance every 6 months. Therefore, there are 2 periods within a year. If interest is compounded quarterly, interest is calculated on the balance every 3 months. Therefore, there are 4 periods in the year. Interest is compounded monthly, then interest is calculated every month. How many months in a year are there? 12. Lastly, interest compounded daily. Then this means the interest is calculated and compounded every day. So there are 365 periods when interest is compounded on a daily basis. So if you take $1 and we say that we have $1 today, we want to know how much is that dollar going to be worth after 4 periods at 8% interest compounding. So the present value is $1. After 1 period, the dollar is worth $1.08. You have earned 8 cents interest on that dollar. After 2 periods, that $1.08 is turned into $1.17 because you're earning 8% on the entire $1.08, and so forth and so on. This can also be shown in this manual calculation. We had $1. Interest is 8%, so at the end of the first year, we earn 8 cents interest. Our beginning balance of $1 plus the interest is $1.08. Now we compound it and calculate the interest on the $1.08 balance. $1.08 times 8% is 9 cents interest. 9 cents plus the beginning balance of $1.08 is $1.17. Carry the $1.17 forward to year 3. $1.17 times 8% interest is 9 cents. 9 cents plus $1.17 is $1.26. $1.26 carried forward times 8% is 10 cents. 10 cents plus $1.26 is $1.36. You see how the amount of interest is gone up each calculation. It's not a simple 8 cents each time. If we only had 8 cents, we would only be at $1.32 because we would have 8, 8, 8, 8. We would have 32 cents plus our dollar. So we would have $1.32 instead of $1.36. It doesn't look like a big difference when you're talking about dollars and pennies. But think about this if you're invested thousands, how this could grow at an exponential rate. When you're calculating compound interest, there's 2 things that you need to know. You need to know the number of periods, the number of years multiplied by the number of times the interest is compounded per year. You also need to know the rate for each period. This is the annual interest rate divided by the number of times interest is compounded in 1 year. So for example, If you compounded $100 for 4 years at 8% interest, what at annually, semi-annually, and quarterly, what are your number of periods and what is your rate per period? So first, number of periods. We have 4 years, and we're looking at annually, semi-annually, and quarterly. Annually, there's 1 period per year, so you have 4 total periods. Semi-annually, you have 2 periods per year. For 4 years, you have 8 total periods. Quarterly, you have 4 periods per year times 4 years, you have 16 total periods. Now, our rate, we need to take that annual rate and divide it by the number of times interest is compounded. So annually, interest is only compounded 1 time. So 8% divided by 1, our rate for each period is 8%. Semi-annually, it happens twice a year. So 8% divided by 2 is 4% per period. Quarterly, 4 periods in a year. 8% divided by 4 is 2% interest per period. So simple versus compounded interest. Bill Smith deposited $80 in savings account for 4 years at an annual interest rate of 8%. What is Bill's simple interest and maturity value? Well, with simple, remember the way we've calculated in the past is interest equals principal times rate times time. So his principal is 80%, his interest rate is 8%, and his time is 4 years. So his interest equals $25.60. His maturity value is his initial investment plus the interest earned. So $80 plus $25.60, his maturity value is $105.60. Now, compounded. Bill Smith deposited $80 in savings account for 4 years at an annual rate of 8%. What is his interest and compounded amount? Well, by hand, we can follow the calculation. $80 times 8%, he earns $6.40 in the first year. $6.40 plus 80, his amount at the end of the first year is $86.40. That's our new balance to calculate 8% on for year 2. 8% of the $86.40 is $691. Add that to the beginning balance to get $93.91. The $93.91 becomes your beginning balance to calculate 8% interest on, or $7.46. $7.46 plus your beginning $93.31 gives you $100.77. $100.77 times 8% is $806. When you add the 806 to the 177, his compounded amount is 108.83. So you can see the difference. With simple, it was 105.60. Compounded, it's 108.83. The difference is 28.83 is his interest that he earns in the compounded method. He only earned 25.60 under simple. He earns 28.83 under the compounded. So that's a lot of steps when calculating compounding year 4. What if you had 20 years worth of calculations? You don't want to have to do that by hand. So we can look it up using a table lookup. Find the number of periods. Years multiplied by number of times interest is compounded in 1 year. So if it's compounded semi-annually for 20 years, you have 20 years times 2, you would have 40 periods. Find the rate. Annual rate divided by the number of times interest is compounded in 1 year. So in our example, if we had the 20-year semi-annual, say it's 6%, 6% divided by 2, the rate would be 3%. You go down the table in the period column till you find the number of periods desired, then look across the row to find the rate. At the intersection of this table, factor for the compound amount of $1. Multiply the table factor by the amount of the loan. This gives you the compound amount. So, for example, if we had 4 periods at 8%, remember he was compounding once a year for 4 years at 8%, our table lookup is 1.3605. Pam Donahue deposits $8,000 in her savings account that pays 6% interest compounded quarterly. What will be the balance in her account at the end of 5 years? First, how many periods do we have? We have quarterly compounding, so that's 4 times a year times 5 years. We have 20 periods. Our rate, 6% per year divided by the quarter compounding gives you 1.5% per period. When we go to the table lookup in 12.1, our table factor is 1.3469. 1.3469 times $8,000 deposited, she would have $10,775.20 in her account at the end of 5 years. Banks often advertise their annual nominal interest rates and not their true or effective rate, the annual percentage, or the APY. This has made it difficult for investors and depositors to determine actual rates of the interest they were receiving. The Truth in Savings Law forced savings institutions to reveal their actual rate of interest. The APY is defined in Truth in Savings Law as the percentage rate expressing the total amount of interest that would be received on a $100 deposit based on the annual rate and frequency of compounding for a 365-day period. The 8% rate is the nominal rate, or the stated rate, on which the bank calculates the interest. To calculate the effective rate, annual percentage yield, or APY, we use the formula interest for 1 year divided by principal. So let's look at 2 companies to see the impact of compounding. Both companies, Blue Bank and Sun Bank, say that they have an 8% interest rate. Blue Bank compounds quarterly. Sun Bank compounds semi-annually. So for Blue, we have 4 periods in 1 year. 1 quarter times 1, we have 4 periods. Sun has 2 periods because it is compounded semi-annually every 6 months. Our stated interest rate is the same at 8%, but we have 4 periods. So our interest per period for Blue is 2%, whereas our interest for Sun is 4 because it only has 2 periods. They both have the same principal amount of $8,000. When we go to the table lookup for 4 periods at 2%, we get a table factor of 1.0824. That times our $8,000 loan tells us that the amount is going to end up being $8,659.20. The ending amount of $8,659.20 less the principal of $8,000 means that we were paid $659.20 interest by Blue for compounding quarterly. Sun, we go to the table lookup. We look up 2 periods for 4%. We get 1.0816. That times our $8,000 principal gives us a total of $8,652.80. That minus our principal of $8,000 says that we're going to have earned $652.80 in interest. So our effective rate, or APY, the interest of $659.20 divided by our principal of $8,000, we have an effective rate of 8.24% for Blue. For Sun, we have $652.80 divided by 8,000, we have 8.16% for Sun. So you see they're both paying you at 8%, but the compounding quarterly versus semi-annually gives you 2 different effective rates. If you have a beginning balance of $1,000 with a nominal rate of 6%, compounded annually, semi-annually, quarterly, or daily, your ending balance in 1 year is 1060, 1060.90, 1061.36, and 1062.70. So your effective, or APY, rate for annually, it's the same as the stated rate, but you see that the more times you compound in a year, the higher the APY is. Interest can also be compounded on a daily basis. This is the table 12.2 that you would use for a dollar being deposited and compounded daily on a 360-day basis. So use table 12.2 to calculate what $900 compounded daily for 25 years will grow to at 6%. So we've got to go down to our number of years is 25, and at 6%, our table lookup is 4.4811. So our number of years in is 5. Our rate should be 6%. Our rate is 6%. So our table factor lookup using table 12.2, which is partially put here, is 4.4811. We invested $900 times 4.4811. Our $900 investment compounding daily for 25 years at 6% will equal $4,032.99 at the end of the 25 years.